All right, I'm glad I didn't have that recorded. Okay, I can see a little bit of my writing on that slide, so that is suggesting to me we got at least that far. All that we have to cover right now are disaccharides and polysaccharides, and I'm not going to dwell on these. I'm just gonna mention them. I do want you to know 3 disaccharides and what monosaccharides make them up. That was pretty clear in the homework. Those 3 disaccharides. Notice that you can't tell the difference between glucose, maltose, ose. They're oses, but maltose is a disaccharide. And yesterday or Monday when you were making your Haworth projections of glucose, and some of you had alpha D-glucose and some of you had beta D-glucose, and I said don't worry about it, don't change it, that's what it is. They're both biologically active, and you can see it right here. Maltose is 2 glucoses, one alpha D-glucose and the other one a beta D-glucose. With this, all right, so notice what you got here. You got a little arrow pointing in this direction. That's what this is. Let's make that a little bigger. See what you got there? So you got an arrow pointing down this direction, saying going in this direction, you're going to split out a water molecule and you're going to make the disaccharide. Carbon, oxygen, carbon, glycosidic bond. Going in this direction, if you started with a disaccharide and you went this direction and reacted it with a molecule of water, you would split it back into the 2 monosaccharides. That's what would happen in digestion right there. If you were digesting a disaccharide, your body would split this bond by hydrolysis. It would insert the water back in that bond, put an H here and an OH here. There's your water, and bam, you got your 2 monosaccharides again, able to be easily absorbed and all that sort of thing. I'm not sure the body might even be able to absorb a disaccharide. I'm not sure about that. But the smaller they are, the easier it absorbs, the easier it transports around, stuff like that. So that's maltose. Sucrose, I think we even got this far. Glucose and fructose. Now this is, on the previous one you saw a 1,4, that's talking about carbon number 1, linking to carbon number 4, that's a 1,4 linkage. On sucrose, here's sucrose, the disaccharide, you got a 1,2 linkage. Here's your glucose, 1, 2, 3, 4, 5, 6, carbon 1. You're linking it down here to carbon number 2 on the fructose. Remember, fructose doesn't have an aldehyde at the end. It's got a ketone at position number 2. So 1,2 linkage, an alpha 1 beta 2 linkage. That's what that terminology is kind of talking about. Yeah, it's a disaccharide. How is it linked? All right, I don't expect you to memorize that level. What I do expect you to know is sucrose is made up of glucose and fructose. But I'm just kind of getting into some of the complexities of these things. Lactose in milk, cow's milk, human milk. You've got lactose, glucose, and galactose. All right, and now this is a 1,4 link, a beta 1 or a beta 1,4 linkage. So you got beta galactose, beta glucose, and that's lactose. And lactose brings to mind 2 diseases. One, early in life, or actually it would be a genetic condition. If someone was not able to metabolize galactose. When an infant is born, they they very quickly, our grandson Judah was born here. Not only was he born here in San Antonio, he was born here in my bedroom. Yes, my bedroom. Because on purpose. My daughter wanted a midwife. And they were living in Cameroon. And here's the story, if you want a little personal story. They adopted a child, adopted Toph. He's 6 years old right now, because they thought they couldn't have children. They adopted Toph and immediately got pregnant with Judah. And a year later had Hadassah. So they have 3 children. But they're living in Cameroon, and my daughter calls home. It's on Skype. Mom and Dad, I'd kind of like to have the baby at home, but we don't have a home, you know? So they're living in Africa. And can we come home and stay with you guys and have the baby at home? So that's what happened.
So it's in your bedroom?
Yeah, in my bedroom. I gave up my bedroom for a maternity ward.
How long was she in labor?
Well, too long. I was in my office entertaining midwives and. Okay, what are we gonna? Who wants another cup of coffee?
That's pretty interesting, man.
Yeah, Judah. So Judah was born December 14th. So they take a blood sample from Judah and send it off. This is when I kind of got, and they do this with all babies right now. They send it off for these genetic tests immediately. They want to see, is there some genetic deficiency in terms of metabolizing certain things or whatever. We talked about the PKU, the phenylalanine, inability to metabolize phenylalanine. This is what they're trying to do with these things. They're trying to detect them as soon as possible so that the child has not experienced any of the detrimental effects by feeding them wrong stuff. So you feed this child milk, and this builds up as a toxic buildup. Galactose isn't toxic, but it is if you can't metabolize it.
Even in mother's milk?
Yeah, even in mother's milk.
Wow. So baby could be allergic, so to speak.
Well, allergic, unable to metabolize this. So I don't know how they would call it that. They may be allergic to milk, but that may be the casein or other things that are in it that are allergic to it. This is a condition where they can't metabolize it. Can't metabolize the galactose. That's galactosemia. Emia means kind of what? In medical terms, that's a toxic buildup of something.
So you brought up Judah to, you you said that too. That was a good one.
I don't know what he said, but it better not have been disrespectful, because he's talking about my grandson. He's in deep trouble. I mean, I'm usually easygoing.
You know what? Just take his extra.
Okay, wait a minute. We got to do that one. There we go. All right. I get off the track with these personal stories. Maltose. We just saw that one again. Just alpha D, beta D, glucose. All right. Don't worry about this one. I could have taken that slide out of there. Polysaccharides. And I'm not going to do a deep dive in here. There's just basically 2 of them that I want you to appreciate. Glycogen and cellulose. There are many other polysaccharides. This would be an oligosaccharide, 3 to 10. Poly, you're getting into bigger, and you can have branching.
It was glycogen.
Glycogen, here you go, right here. Glycogen, cellulose. Glycogen, the importance of that. So that's in your body. When you have an excess of glucose, it's being absorbed into the cells of your body, and you've eaten, and your body says, you know, I bet you, but if this guy misses dinner, we're going to need some more of this glucose later. So they store it as glycogen. And you get 6-8 hours, you miss dinner, whatever, it starts clipping that glycogen back down into glucose and releasing it into the bloodstream. So this is in the liver and the muscles. It's forming glycogen. So that is a polymer of all glucose. It's just a polysaccharide of glucose. And it can have some branching on it. Glycogen. So each one of these beads would be representing a glucose molecule. So hundreds of glucoses. And the body just keeps adding them on there. If it has an excess of glucose, and then it clips them off of there when the blood sugar level lowers. So, yeah, so it's going to form the glycosidic bond, and if it needs glucose, it's going to hydrolyze that bond and clip it back off again, metabolically. Cellulose, most abundant organic compound in nature. Corn stalks, branches, oak trees, tree trunks, all that stuff is cellulose, which we don't digest. This would be fiber. So we went through a phase there where it said you don't digest it, don't eat it. Why you don't digest it, don't eat it. Now we're in this phase where it says, you need some stuff in your system that doesn't digest. Carrier, whatever it is doing in there, filling up your intestines, you need some non-digestible fiber in your diet. I don't know how much, but you need some fiber. So this would be fiber. Cows, this is what cows are chewing on. They have so many different stomachs that they can digest it. And they have certain bacteria in some of those stomachs that can break cellulose down, and so they can live off of this, but we can't. Cellulose. And it is highly cross-linked. And I think I mentioned in here the other day, you know, how strong this makes this polysaccharide, so that you can have tree trunks and things like that. It's very highly cross-linked. It's not like a spaghetti sitting there, it's just flopping all over. It's like spaghettis that are all tied into each other, and they're nice and stiff and hard and strong. Cellulose. So that's about all I want to say. There's cellulose, 1, 4, 1, 4, and then there would be branches coming off of here, but it is a polysaccharide. And we mentioned this one already, blood type. Okay, so, and those are little oligomers coming off the side.